Hey third graders, I know it's a little dark in here, my lights went out, but I hope you can see me fine. Our I can statement for today is I can solve two-step word problems and write proper equations for them. So another day of two-step word problems, that just means we're gonna get better and better as we keep doing two-step word problem lessons. So I'm super excited about that. And today we're actually adding in some PEMDAS. Instead of writing two different equations, we're gonna put them all into one, okay? We've done it before. We're going to get better now. Let's go. To start off, let's remind ourselves of a couple of our multiplication and addition properties, okay? The commutative property of addition just tells us that we can rearrange the order that our numbers are grouped together and we'll still get the same answer. So for example, 40 plus 30 plus 60 in parentheses is the same thing as 40 plus 30 in parentheses plus 60, which is also the same thing as 100 plus 30, because 100 just equals 40 plus 60, right? So you can make your problems easier by grouping numbers together that are easier for you to solve, right? Perfect, let's keep going. Our next addition property is the identity property. The addition identity property deals with the number 0. That 0 doesn't steal the identity of any other number if you add it in there. So 334 plus 0 is still 334. The 0 didn't take 334's identity. It's still the same, it's still 334, it didn't change. That's the addition identity property. Now let's switch it up and do the identity property of multiplication. The multiplication identity property deals with the number 1, not 0. So 1 doesn't take the identity of any other number when it's multiplied with it, if that makes sense. For example, 37 times 1 is still 37. 1 didn't change 37 at all. It's still 37 even though it was multiplied by 1. Okay, so the commutative property of multiplication is just like addition. It's just saying that you can rearrange the numbers and group them in any way and your answer is still going to be the same. For example, 2 times 8 times 5, let's solve it and see if it's the same thing as 8 times 2 times 5. So 2 times 8 equals 16. Then I bring down my multiplication sign. I bring down my 5 because those I have not used yet. And 16 times 5, I know you don't know it, it's 80. Okay, so we got 80. Now let's do 8 times 2 times 5. 2 times 5 is 10. 8 times 10 equals 80. So yes, they equal the same thing, but you can move around the numbers to work for you. For example, it's going to be easier for me to multiply 8 times 10 because I know how to multiply by 10, and it's going to be harder for me to multiply by 16. So you can rearrange the numbers to make it easier for you. Next multiplication property is the distributive property. This one was a difficult one for us when we first learned it. So let's go over it one more time, okay? 9 times 8 is the same thing as 5 times 8 plus 4 times 8. And the reason for that is I can take one of these numbers and break it down. So I'm going to break down 9 into 5 and 4 because 5 plus 4 is 9, right? Perfect. So now what I'm going to do is put that 5 times 8 because I've still got to use the multiplication in 8. So I'm going to use both of these numbers, 5 times 8. So now I've used up the 5. I have to use up my plus, so now plus. And then I have to get rid of this 4, so I have to do 4 times 8. So now I have the same thing. I've got 9 times 8. That's the distributive property. It's just saying I can break up my number and multiply it with the other number to make things easier for me. Because now I can just do, 5 times 8, that's really easy. 5, 10, 15, 20, 25, 30, 35, 40. Oh, it's 40. Plus 4 times 8 is just 32. So my answer is 72. So that might be easier for you to solve than doing 9 times 8, which are bigger numbers. You just do the smaller numbers and then add them up. That's the distributive property. Okay, So next is our zero property. The zero property just says 0 times anything is just going to be 0. Any which way. So 0 could be the front, 0 could be the second number. It's going to equal 0 any way you do it. The biggest number you can think of times 0, still going to be 0. I could have 3 numbers multiplied together. 3 times 0 times 5. My answer would still be 0. If there's a 0 in the multiplication, the answer is 0. That's all the zero property is saying. Okay, this one's a little complex, this first problem we're going to do. So just stay with me, we'll think through it, we'll solve it together. Here's the problem. Lauren had a 36-inch piece of ribbon. She cut a number of 3-inch pieces from it. There are 15 inches left. How many pieces did she cut off? Okay, there was a lot of words in there, a lot of pieces, a lot of inches thrown at us, and so I'm a little confused. Take some time, think about what it's saying. I'm going to take some time. Okay, sometimes I like to draw a picture. So I've got 36-inch piece of ribbon. I'm going to draw that, a 36-inch piece of ribbon. Okay, I'm starting to understand more because I'm drawing a picture. Got my 36-inch piece of ribbon. She cut a number of 3-inch pieces. Now, I don't know what number that is, so I can't draw it on here. I have no idea how many she cut, so there's no way I can draw it. So let me draw the next thing I know. There are 15 inches left. Okay, I know now that there are 15 inches left on this 36-inch piece of ribbon, so I'm going to draw what is left now. Okay, so now I've labeled what is left. This blue piece of the ribbon is what I have left. It is 15 inches. Let me find my red. Here it is. So that means this whole piece was cut off into 3-inch pieces. Now that I understand what the problem is saying, let's see if I can write an equation to go with it. Now, there are 15 inches left. That sounds to me like the end of a problem. So what is left? That means it equals 15. There are 15 inches left. So I'm going to start there. She had 36, so she had 36. I'm going to start with 36 because that's how many she had. She started with that many, so that's what I'm going to do. Then she cut a number of inches from it. So that means she took away. So taking away from 36, perfect. Now, a number of 3-inch pieces. How am I going to figure out what that number is? This is what you do. In order to figure that out, we've got to use a variable, okay? Now it says a number, so I'm going to use the variable n, and it says a number of 3-inch pieces. That word of tells me multiplication. So a group of 3-inch pieces. So I'm doing n, a group of, I don't know how many groups, but a group of 3-inch pieces. That is my equation now. Now I get to solve. This is where it gets tricky, so please try and stay with me here, okay? We are going to do some algebra. I'm going to erase my picture, and then I'm going to show you how to do this, okay? We can do it. Stick with me. Okay, let's solve. So basically, all I have to do is figure out 36 minus what equals 15. I'm going to put this in parentheses because this is what number subtracted from 36 is going to get me to 15. And then I can fill out n. I can fill out n after I figure that out. In order to do that, let's just do 36 minus 15. So here we go. 36, and let's stack up our numbers because that's how we like to do our subtraction, right? 36 minus 15. 6 minus 5 is 1. 3 minus 1 is 2. Okay, so this whole thing has to equal 21, right? That whole thing right there. N times 3 has to equal 21. So, what times 3 equals 21? In order to get that, we do, and my board's getting a little crowded, so I'm going to erase this over here. we can change this because it's saying what times 3 equals 21, and we know I can change that to division. So 21 divided by 3 equals what? And the answer is 7. So now we know that n equals 7. That was a long ride, took us a lot to get there, but we did it and you got through it. Let's do another one, a little more simple. So we just got through a complex one. This one's complex, but we already did one, so it's going to be a little easier. Let's try. There are 47 students in the band. There are 5 students in the first row, and the rest are in equal rows of 6. How many students are in each row of 6? This one I want to draw a picture because I can't understand what's going on unless I draw a picture. So here I go. There's 47 students in all. Okay. 5 students are in the first row. So let me just draw the first row. That's what they tell me. Okay, 5 are in the first row. 1, 2, 3, 4, 5. Great, got it. The rest of the students are in equal rows of 6. Okay, so now it sounds like I'm going to have to make rows of 6 until I get to 47. Right? Yeah, I could do that. So I've got 5 students already. Let's make some rows of 6. 5, 6, 7, 8, 9, 10, 11. All right, there's one row of 6. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Okay, I'm going to make a row of 6 over here. 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. Okay, I got to 47. I made all my rows. Right here is a barrier because those aren't part of the other rows. So now I have to figure out how many students, that's the wrong question. I wrote it down wrong. It's how many rows of 6 are there? Because obviously there's 6 students in each row, so that was ridiculous. How many rows of 6 are there? I knew that looked weird. Maybe you guys caught it too, but you can't tell me because we're not in class, huh? All right. So now I can find the answer really easy with my picture. I can just count and see there's 1, 2, 3, 4, 5, 6, 7 rows. So I know my answer is 7, right? But this lesson's all about writing the equation. So let's do that. We just have to think about what we did and turn it into an equation. First, we started out with 47 students. So there were 47 students in the band total. But we were breaking that up into different groups. So this is division, and in division, our total is always our answer. So let's put that as the answer. So something is going to equal 47. Oops, not 46, 47. Now let's think about how we can get to 47. So what did we do? Well, we started with a row of 5, right? And then we had to add on all of the other rows. So 5 plus however many rows of 6. At first we didn't know how many rows there were, so we were going to say a number of rows of, which is our multiplication sign, of 6 students. So that means we add our row of 5 plus, and I'll put this in parentheses so it's easier for us to see, plus however many students are in all of these rows of 6. And then we can figure it out. And with our picture, we know that n equals 7. So 7 times 6 is 42. And 5 plus 42 equals 47. That's how I check my answer. Okay, those were tricky, but you guys can do it. You can head on over and do Think Central. I love you. I miss you.